Hello everyone and welcome back to Educator.com. In this mini lesson we're going to go over the first page of the A+ Physics worksheet on momentum and impulse. And you can find that worksheet by clicking on the link down below. Take a minute or two, print it out, try and go through it, see if you got them right, see if you can solve them, and then check here and we'll see if we got them right. So problem 1. We have a 1,200 kilogram car traveling at 10 meters per second. So mass is 1,200 kilograms. Traveling at 10 meters per second, and it's brought to rest in 0.1 seconds. So this must be our initial velocity. Our final velocity is 0, and the time it took is 0.1 seconds. What's the magnitude of the average force acting on the car to bring it to rest? Well, in order to solve this one, I'm going to have to use the relationship that impulse, which is a change in momentum, is equal to force times time. But our change in momentum, well, that's going to be change in mass times velocity equals force times time. But mass isn't changing, so on the left-hand side, this will be mass times change in velocity equals force times our time interval. And delta V, that's change in velocity, that's final minus initial, so that will be mass times final velocity minus initial velocity equals F delta T. And finally, I'm actually looking for force, so let's rearrange that to say that force then is mass times change in velocity divided by our time interval, where our mass then is 1,200 kilograms. Our change in velocity is going to be our final velocity, 0 minus our initial, 10 meters per second, all over our time interval of 0.1 seconds. So, as I do this, I'm going to have 1,200 times negative 10 divided by 0.1, or negative 120,000 newtons. And since we're only looking for magnitude, that's 120,000 newtons, or 1.2 times 10 to the 5th newtons. Best answer there, number 4. Looking at number 2, a 50 kilogram student, M equals 50 kilograms, threw a 0.4 kilogram ball, so the mass of the ball is 0.4 kilograms, with the speed of 20 meters per second. V equals 20 meters per second. What was the magnitude of the impulse that the student exerted on the ball? Oh, so if we're focused on the ball, it started at rest. V initial must have been 0 meters per second. We want to know impulse. Impulse is change in momentum, which is going to be our final momentum minus our initial momentum, which implies then that our impulse is going to be, well, our final momentum is just mass times final velocity. That'll be 0.4 kilograms times our final velocity, 20 meters per second, minus our initial velocity, which is 0 because the ball started at rest. Therefore, our impulse is going to be 20 times 0.4, or 8 Newton seconds. Best answer there, number 1. Looking at number 3. In the diagram below, a 60 kilogram roller skater exerts a 10 Newton force on a 30 kilogram roller skater for 0.2 seconds. What is the magnitude to rest. The time interval is 0.5 seconds, so to solve for force, that's going to be change in momentum divided by time. Our change in momentum is our final momentum minus our initial momentum, 1200, divided by our time interval, 0.5, or negative 2400 newtons. And since we're only looking for magnitude of the force, 2400 newtons is our answer. Choice 4, 2.4 times 10 to the third. Number 7, we have a 70 kilogram hockey player skating east on an ice rink, and the hockey player is hit by a 0.1 kilogram puck moving toward the west. The puck exerts a 50 Newton force toward the west on the player. Determine the magnitude of the force that the player exerts on the puck during this collision. Well, if the puck exerts a 50 Newton force toward the west, then the player must exert that exact same magnitude of force back on the puck to the east. So that must be 50 newtons back. Again, Newton's third law. Number 8. Which situation will produce the greatest change in momentum for a 1 kilogram cart? Remember, change in momentum is impulse, which is force times time interval. Accelerating it from rest to 3 meters per second, well, that's going to be a change in momentum of 0 to 3, so 3 kilogram meters per second. Accelerating it from 2 to 4, that'll be 2 times 1, or 2 kilogram meters per second. Applying a force of 5 newtons for 2 seconds, force times time, that'll be 10 newton seconds. Or applying a force of 10 newtons for half a second, that'll be 5. Without a doubt, the largest impulse or change in momentum will be number 3, 10 newton seconds, or 10 kilogram meters per second. Let's try one more. A .149 kilogram baseball initially moving at 15 meters per second is brought to rest in .04 second by a baseball glove on a catcher's hand. The magnitude of the average force exerted on the ball by the glove is, well, once again, impulse is change in momentum, which is force, times time, and we're looking for force. So force will be change in momentum divided by time. Now, the initial momentum of our baseball is its mass times its initial velocity, or .149 kilograms, times 15 meters per second, which is going to be about 2.235 kilogram meters per second. If it's brought to rest, its final momentum is going to be 0. So change in momentum is final minus initial, which will be 0 minus 2.235, or negative 2.235 kilogram meters per second. So the force is delta P over delta T, or negative 2.235 kilogram meters per second over our time, which was .04 seconds. So that will give me about negative 56 newtons. But because we're only looking for the magnitude, correct answer, 56 newtons. All right, hopefully those went pretty well for you. If they did, great, go ahead and move on. And if they didn't, now'd be a great time to go review the longer lesson on momentum and impulse. Thanks everyone for your time, and make it a great day.